In learning target 2, we're talking about a special type of piece. It's called a step function or a greatest integer function. This is a new thing. Just like you learned absolute value before, you learned how to square stuff before, this is a new thing. You've never seen this before probably. And so you have to listen so you know what it means. This symbol right here, the brackets, the double brackets, indicates your greatest integer. It would be helpful if you knew what greatest integer meant. First of all, an integer is a number line number. So there's no fractions or decimals. So integers are like -5, 0, 3, 120. When you're looking for the greatest integer, you're looking for the greatest integer that's not greater than x. So you're for the largest number that's not bigger than what you put into the brackets. So before we even start graphing anything, I have 3 examples at the top of your paper. The first one says to find the greatest integer of 5.4. That means I am looking for the largest number, largest integer that is not bigger than 5.4. 5. The greatest integer, the largest one, that's not larger than 5.4 is 5. We'll get there. For 9.9, the greatest integer, not larger than 9.9 is what? 9. The greatest integer that is not larger than -4.3, -5. -4 is larger than -4.3. Draw a number line if you have to that you are trying to think it through. The negative. So draw a number line if you have to. Do those make sense? You're going to have to be able to use that function in order to graph something because you have to be able to figure those types of numbers out in a table. Okay? So it just means the greatest integer that's not bigger than whatever's in the parentheses or in the bracket. The negative ones are the only ones I think that are super tricky. Okay. Oh, we've got a graph, and I will do more examples if I need to today, but I have one on your note sheet and one on here. So it's to graph the function, and it says negative greatest integer of x. Now, the negative is not inside the brackets. So the negative is going to be like an after thing when you do the table. Now, in order to illustrate what's going on this graph, you have to use decimal values in your table. So I'm going to use the following numbers. You can use whatever numbers you want to, but I'm going to use integer values as well as decimals because I need to know what's happening in between the integers. Yeah, I'm just doing an integer and then some decimal value in between there. Okay. All right. So when we put these numbers into the function, the integers are not trick questions. So if you put 0 in for x, what's the greatest integer that's not bigger than 0? 0. It's just itself. Yes. Yes. There's a negative out front, but you can't have -0, so it's just going to be 0. Then if I put 0.3 into the brackets, what's the greatest integer not greater than 0? 0, and again, it can't be negative, so we're just leaving it at 0. Yeah, so if you put 1 into the brackets, the greatest integer that's not greater than 1 is 1, but there's a negative in the front, so -1 is what's going to go in our table. It's not bad, it's just you have to think about it. The greatest integer not greater than 1.7 is 1, but there's a negative, so -1. The greatest integer not greater than 2 is 2, there's a negative, so -2. I think you can see how this is going to go.
Now, if that negative's on the inside of the bracket,
Then it would change your answer. Because if it was on the inside, just for argument's sake, and we were doing 1.7. So if you were doing 1.7, you'd have -1.7, and what's the greatest integer not greater than -1.7? -2, right? We had -1, so this would be -2. So that's a different function. Okay. Okay. All right, now you have to pay attention when I'm graphing this, and you're going to have to listen to what I'm saying while I'm graphing it as well. Okay? We're going to graph the first point, 0, 0. Point on the graph, not a big deal. We could graph, and I will, but you don't have to. But 0.30 is also a point on the graph. Agreed? Every point in between 0 and 1, right? You could use whatever decimal you wanted to between 0 and 1, right? So every single one would be 0. All the way up until when you get to 1. But 1, it changes, right? Now. Right, yes, until x equals 1. Yeah, and then it changes in our table. So, what you need to know, though, is that you have to have a closed circle at 1, because 0.99999999999 is still, the greatest integer is still 0. So it's all the way up until 1, but not including 1. So I'm going to have an open circle here, and I'll fill in between there, just with a line. If you want to, that's fine. It's fine if you want. But you'll always have this entire part filled in. So for the next part, like 1, -1, is right here. That's a closed circle. That's an actual point on our graph. And like 1.7 -1 was also a point on our graph. Every single decimal value between 1 and 2, x equals 1 and 2, would have a greatest integer value of -1, all the way until you got to 2. So we put an open circle at 2 and fill in between. And this keeps happening. Yeah, because that's a point on our graph, like on our table. You don't have to keep graphing this, but this is what it'll look like. Because every decimal value in between is going to have the same value. No. You just don't do it that way. Nope. So yeah, make sure, so that's a good question. You're not drawing like an actual slanted line anywhere. It's not like a linear function. You're just drawing a bunch of little stairs that aren't connected. That's why I said at the beginning of it was called a step function or a greatest integer function. You should probably have like 4 or 5 steps. Yes, because that's part of the function. That's why we had the table. Like at 1.7, you got a function value of -1. You have to have a point, like a line there to represent that. Every number between 1 and 2 is going to have a function value of -1 in this table, except for 2. And then it changes. When you graph a linear function and you're graphing the points, do you leave a blank in between the points? When you graph a line, Houston, when you graph a line, like we did earlier when we talked about piecewise functions, I graphed these points with the purple ones, but I connected them, right? It's the same thing because all the values in between those points are still on that line. I'm going to do one more example to make sure everyone's on the same page.
So are there going to be functions in this?
What do you mean?
Like f of x of that greater than or equal to 3?
It's not going to be a piecewise. No, it's a special type of piecewise. Okay, let me make one up real fast, and then I'll let you work. Let's do, this is, you can write this on the back if you want to do it with me, I don't care. Let's do the function values here. F of x equals greatest integer of 3x minus 1.
Now, are those two brackets side by side?
Yeah, it's like a weird bracket thing. It's like I don't even know. It's like a weird bracket thing. I don't know what to call it.
Oh,
yeah, so we're going to make our table, and I'm going to use similar values like I did last time. Not the exact same one, but I'm going to use decimal values in between.
so what do you add there? 0.2 every time?
I'm just making up numbers in between.
This should be random. Doesn't matter. What?
All right. I wouldn't give you ones that are super complicated, like this. Okay. You could do the ones you need to do. All right, so if x is 0, 3 times 0 is 0. The greatest integer that's not greater than 0 is 0, and 0 minus 1 is negative 1. Okay, so 0.2 times 3 is 0.6. And the greatest integer not greater than 0.6 is still 0, and 0 minus 1 is still negative 1. 1 times 3 is 3. Greatest integer not greater than 3 is 3, and 3 minus 1 is 2. You should look at them so make sure you have the same pattern. 1.7 times 3. That might get tricky, right? 1.7, I know. It's 5.1. The greatest integer not greater than 5.1 is 5, and 5 minus 1 is... So this is going to get tricky. You have to look at some stuff going on. 3 times 2 is 6. Greatest integer not greater than 6 is 6. 6 minus 1 is 5. 2.3 times 3. And then the greatest integer not greater than 6.9 is 6, and 6 minus 1 is 5. I'm doing this to make a point. Okay. I'm going to do this one, 3.6. 3 times 3 is 9. Greatest integer is 9. 9 minus 1 is 8. 3 times 3.6 is 10.8. Greatest integer not greater than 10.8 is 10. And 10 minus 1 is 9. There is not a single one on your homework that's this complicated. I'm doing it to make a point. I want you to look at the pattern, though. The decimals that are smaller stay the same. The ones that are larger are different. So what do you think that equalizing point is? If you keep your decimals so small, it's fine, but what happens to the larger ones, though? It's going to affect where that line starts and doesn't start. What? On the graphing calculator? On here? Yeah, I can graph parts of it. But I'm going to need more information. Like, I need to know when it turns into 4. No.
It's not a constant line.
It's got to be a straight, like, yeah. Okay, so we could keep doing some stuff. Like we could look at with numbers between 1 and 2, for example, like 1.4 times 3 is 4.2, so 4 minus 1 is 3, right? That's even different than what we got earlier, right? So there are none like this that are super tricky, but I want you to notice this because I want you to not think that you just do little straight lines like this every 5 seconds and that you don't have to do a table and you're going to be fine. I would not give, you can't use your graphic calculator anyway. I'm not giving one of like this for you to do. They're all very simple, one-step things. But I want to show you what it would look like. Okay, I'm almost positive this is the right one. I could be wrong. Here, let's test that out. I'm almost positive that's the right one. I'm just testing out that I'm using the right one. Okay. So, like, there's gaps. It's not just like what we did it 5 seconds ago. Yeah, there's still straight lines. I'm trying to show you it's not going to be like you don't have these slanted lines. You won't have any of that complicated. All I'm worried about is easy ones. Like, you might have the greatest integer of 3 times x, which is 3 times x, but not the minus 1 part. Or you might have the greatest integer of x plus 1. But you're not going to have, like, all this, like, crazy stuff going on. It's going to be fine. Okay? I was just doing it for argument's sake. But you can't just think, oh, we're just going to draw a bunch of lines and be done. Okay? All right.